module is all about the teenage brain, your brain. And yes, it's still under construction. The brain you have today doesn't look anything like the brain that you had 5 years ago, and it doesn't look like the brain you're going to have in 10 years from now when you arrive in your mid-20s. We didn't know this just a few short years ago. Because of fabulous technology like fMRIs, functional magnetic resonance imaging, that allows us to see where the blood flows in the brain, and other new technologies, we are learning a lot about the brain. So you're going to need to learn some brain basics in order to get the most of this module. So don't stress about the anatomy part. We're going to go into greater detail about brain anatomy in a further module. But for now, you need to know at least some basic vocabulary. So let's jump right in. Firstly, you need to know that your beautiful brain has been evolving for millions of years, beginning as far back as, about 6 million years ago. Why do you need to know this, apart from the fact that it's just really interesting? Well, it's because the brain we all enjoy today came to us in evolutionary stages. This is not just our ancient past, but our present, because your brain matures from the back or from the oldest part to the front or to the newest part. And in a very real way, the ancient lizard brain or reptilian brain and the mammalian brain or the limbic brain are an integral part of the modern brain that we have today. This is called the triune brain theory. According to this theory, the three distinct parts of the brain emerged during the course of evolution and now coexist within the human skull. We have three brains in one. They are called the reptilian, the mammalian or the limbic, and finally the neocortex. These three brains are intricately tied to each other through many neural pathways. A neural pathway is simply the highway of cells that connect the subcortical or the inner parts of the brain to the cortical or the top parts of the brain. So if you see here on the left, you'll see the inside limbic brain. You won't see that when you're looking at a brain. You'd need to split the brain, open it up, and look inside. It's hidden deep inside. And all that wrinkly stuff, that's the neocortex that sits on the top. So the inside parts of your brain talk to the top part of your brain by these neural pathways. That means that the older reptilian brain will influence your behavior before the newer neocortex can do anything at all. We will learn more about that on modules dealing with emotions, habits, and motivation a little bit further on. Evolution is endlessly fascinating. Before human beings evolved into Homo sapiens, the brains on the planet belonged to the lizards. Then from there, the tree of life produced mammals. But because evolution is efficient, nature did not design an entirely new brain, but simply issued an upgrade of the existing reptile model. Now fast forward several million years, and the first hominids, or creatures that looked like humans, appear with the beginning of what we now call the cerebral cortex, or the wrinkled gray matter. That's the stuff that you see at the top. We share this cerebral cortex, or sometimes called the neocortex, with other primates and mammals. This cortex is where all of the thinking happens, but more about that later on. Let's look at Homo habilis, an early hominid from 2.5 million years ago who had ape-like features and a very small brain with a volume of approximately 600 cubic centimeters. We call him habilis because he made tools. You think of the French habile. Let's jump forward in evolution 1 million years to Homo erectus, probably the first to use fire, and the hominid that began the mass migration leaving the plains of Africa. His brain was a huge 400 cubic centimeters bigger than Homo habilis. Scientists now know that the brain adapts or evolves because it needs to respond to changes in its environment. We also know that during periods of dramatic climate change is when we see the greatest growth spurts in the brain from an evolutionary perspective, of course. The modern day brain on the right is approximately 1400 cubic centimeters, and this visual gives a really good idea of the difference between Homo erectus and us, Homo sapiens. This is a great website maintained by McGill students whose purpose it is to help the public learn all about the brain. As I mouse over the different brain layers, you can clearly see the 3 stages of development. First, the reptilian brain, and in red, you can see the brain stem and the cerebellum. Next, the mammalian brain, and finally, the amazing Homo sapien brain, the neocortex, that produced language, culture, space travel, and nuclear medicine, to name only a few things. It's fascinating to think that our brain parts are shared with lizards and bunny rabbits. The reptilian brain includes the brain stem and this part called the cerebellum, or Latin for little brain. Essentially, the brainstem keeps all the unconscious and automatic processes like breathing, heartbeat, body temperature, and much more working very smoothly. You don't have to think about that. It's like autopilot or cruise control. The cerebellum helps us coordinate motor movements, so posture, dance, coordination, and even some speech are controlled by the cerebellum. When people are intoxicated and have trouble walking, it's the cerebellum that has been compromised by the alcohol. The next level up in our evolution is the limbic brain, or the mammalian brain. Sometimes it's called the emotional brain. This brain is responsible for creating the 6 basic human emotions of happiness, fear, sadness, anger, surprise, and disgust. The structures of the emotional brain, or better called the limbic system, are many, and we will examine them in more detail in a future module when we learn about the biology of emotions. But for today, let me introduce you to your amygdala. The amygdala, because they come in pair, one for each hemisphere, is an almond-shaped cluster of cells that are responsible for your emotional states. Reptiles don't have amygdalas. They might make cute pets and you might have some feelings for them, but they don't have any feelings for you. The amygdala is a tiny almond-shaped structure at the heart of the emotional brain called the limbic system. All mammals have limbic systems. This is where our primary emotions come from, especially fear and aggression. The amygdala takes in sensory information and produces an immediate emotional response to the stimulus that we see, feel, hear, and experience. If something is threatening or perceived as threatening, we feel fear, and then the fight or flight response kicks in. There's no thinking happening here. It's simple, pure reaction. This is rapid and automatic. Imagine a primitive human being, pre-language, walking down the path of the African savanna, completely oblivious to the tiger rustling in the bushes next to him. How long do you think he would have survived? His amygdala not only jump-started his physiological response, sending blood away from his core to his extremities so he could run for his life, but that same amygdala also made sure that he remembered that event so that in the future any rustling in the bushes would be associated with the fear response, and he would forever remember to run for his life when the bushes rattled, or aim a spear if he was hunting. So emotions help us learn, and this little amygdala saved primitive man, allowing the species to evolve. You are here because of this wonderful amygdala. What would have happened to us if we never experienced fear or pleasure? We learn because we can connect stimulus to either something positive, a reward, or something negative, a punishment. We learned to avoid tigers because we felt fear and because we remembered the stimuli surrounding that fear, like rustling in the bushes. And finally, the neocortex, or sometimes called the cerebral cortex. It's the thinking, rational part of our brain, and it's the last phase in the evolutionary development of the human brain. We share our neocortex with primates and other mammals like whales and dolphins. The neocortex is why we developed language, culture, abstract thought, imagination, tools, and technology. This is the part of our brain that can tell the amygdala producing panic because it misinterprets a stick on the path to be a deadly snake to relax. It's only a stick. At the front of this cortex, or this neocortex, is the part called the prefrontal cortex. Here in this picture you see it's called the frontal cortex. This is the CEO of the brain. This prefrontal cortex coordinates everything. It plans, it strategizes, and it can mitigate, that means to calm down, the raging emotions coming from the limbic system. You know, when your parents tell you take 3 deep breaths when you're angry instead of blurting out what you really want to say? This is a strategy that gives the prefrontal cortex time to speak to the amygdala and tell it to calm down because there is no real threat here. Relax. It'll all be okay. This prefrontal cortex is the CEO of your brain. It receives input from all other regions and plans, directs thinking and behavior. The prefrontal cortex is like the filter for your emotional brain. It modulates moods. It takes time to consider the facts of a situation. It understands context. It weighs pros and cons, makes a decision, and plans strategies. The prefrontal cortex is what you use when you self-regulate, like saying no to a temptation, or wisely planning your daily activities with a balance between fun and duty. You have learned about the triune brain and also about how the brain evolved. You have seen that parts of our brain are designed to react, to think, and to feel. There are some circumstances where we have little or no control and the reptilian brain will simply react, like blinking your eyes to avoid a foreign substance from entering. As you progress throughout this module, you will see different contexts in which the frontal cortex or the prefrontal cortex is in control, and others where you see the limbic system is clearly in charge. This is a great visual. It shows you how the brain, only 2% of our entire body, really burns approximately 20% of all of the calories you eat in one day. Do you know how after a lot of exams and a lot of studying, you're really tired? You haven't been running around, but you're really tired? That's because thinking takes a lot of energy. It's a lot of hard work to really stop and think something through. Resisting the temptation of bad habits takes a lot of energy. Keep that in mind as you continue through the rest of this module and learn about the teenage brain.